Hey, let's look at the spherical coordinate system with respect to the Cartesian coordinate system. Let's get started. So the Cartesian coordinate system, I'm not going to redraw it again. I'm just going to draw the spherical coordinate system. By the way, the spherical coordinate system got its name much like the cylindrical coordinate system from the word sphere. So you can convert it into a sphere. When you join the dot, you join the lines, you get a sphere. Anyways, so as I said, we need this perpendicular always. Now in spherical coordinate system, since we are not really drawing something, the question that arises is, do we really need a perpendicular? Yes, we do need a perpendicular, because this perpendicular is going to help us big time. But how? Let's see. First, we are going to drop this perpendicular, and then it's not just going to have one line from the origin, it's going to have two lines beginning from the origin. So we need to keep that in mind. So keeping that in mind, we are moving on. So this is the first line, and this is the second line. So this line we are familiar with, so I'm just going to turn it into a red color, since we are familiar with this line. So it sort of got black. Sorry for that. And obviously this line, I'm trying to mix the spherical and the Cartesian for you. You might have noticed this, but don't worry, it's an easy way of learning. X, and this is my Z, and this is my, okay, let's just leave this for now. Let's concentrate on this. I'm going to name it rho. Okay, so we know it's rho, but I'm going to call it A. Okay, so I'm calling it an A, because it's not a cylindrical coordinate system, it's a spherical coordinate system, so I'm going to call it an A. Although I know A and rho are the same, and they have the same values, but anyways, I'm going to give it a name, A. And this green line is going to be the radius of the sphere, so it's going to be R. Now if I draw, if I try drawing a shape from this point, you would find that I get a sphere, because this is a three-dimensional one. You cannot really feel it in a two-dimensional plane. So let's say this is a sphere. There it goes, and it breaks. Okay, I think that's a sphere. Yeah, pretty much like an oval. Okay, so that's an R, that's my A, which is also equal to, let's write for our information on the side, A is equal to rho. So we know what A's equation is, so that it's easier for us when we are bringing down equations, and when we are finding out relativity between the spherical and cylindrical coordinate systems. So now let's just continue. So the R and the Z, yeah, there are two angles over here. There's just not one angle, there's going to be two angles. So the first angle is going to be, as usual, the phi from the x-axis, starting from the x-axis and moving towards the A, or the rho. And the second angle is going to be theta, starting from the z-axis. Well, this is the z-axis, starting from the z-axis and moving towards the radius. That's going to be theta. Okay, so we are going to be finding equations for r, theta, and phi. Let's find out. R. What's r? Before we find out r, we need to actually find out what's A, and we know that. We know A is equals to rho is equals to under root x squared plus y squared. We also know that phi is equal to tan inverse y by x. Now what we don't know is r, so we got the base, we got the height. All we need is the hypotenuse. So as I said, we dropped a perpendicular. That means this is perpendicular. This is also 90-degree angle. So it's clear that this r, or the radius, is also another hypotenuse. So this hypotenuse becomes the side for this triangle. Okay, so let's say we have A. So let's apply the Pythagoras rule again. So it's r is equals to under root a square plus z square. That's going to be under root x squared plus y squared plus z squared. Okay, so now we have r, that's this, we have phi, and what's left? We are left with theta. So how do we find theta? We find theta is simple. All we need to do is bring theta inside. How we do that? It's basically alternate interior angles. So alternate interior angles is one of the property of parallel lines. So this is the parallel line since it's a subset of z-axis. So let's just bring that in. This angle is also the same thing. So this is r theta. So it's now comparatively easier to find theta. So theta is equals to opposite by adjacent, tan inverse a by z. So let's do that. Theta is equal to tan inverse a by z. Now tan inverse under root x squared plus y squared by z. So this is my theta. So I got my theta, I got my r, I got my phi. What else do I need? I don't need anything else. But we also need to understand the spherical coordinate system with respect to the cylindrical coordinate system. So this was spherical coordinate system with respect to the Cartesian coordinate system, guys. Okay. Thank you.